Good morning. Today we will see in this video the problem on star to delta transformation and delta to star transformation. For this example, let us to find the value of voltage source Vs that delivers us the 2 ampere current through the circuit as shown in figure. From this figure, there are voltage sources, the unknown sources. The current is flowing through this circuit is the 2 ampere. The 1 ohm resistance that in series with the equivalent resistance of this whole network. There are 2 ohm and 1 ohm are connected in series. Similarly for 0.5 ohm and this 0.5 ohm are connected in series. So we have seen here to read this circuit. Here there are these two resistance are connected in series, and to form there are delta fashion, and here is also to form 0.5 ohm and 0.5 ohm to form the delta fashion. So there is a necessary to convert from delta to star here and delta to star here for sake of the simplicity. So here is the resistance 2 ohm and 1 ohm are connected in series fashion, and 0.5 and 0.5 are connected in series fashion, so that there is a necessary to convert from delta to star transformation. So here is A of AO, OD and OC we have to be calculated. So A of AO means for this resistance there are A of AO, there is a 3 into 1 upon 5 means the total resistance. Means in this way there are, this is the total resistance. AO means A, for here there are total resistance 3 into this is the 1, means A of B and A of C we calculated. A of B or A of D, there is a 3 into 1 upon total resistance 2 plus 1 3 plus 1 4 plus 1 5. In this way we calculated A of AO, the resistance R of AO, which is equal to 3 into 1 upon 5. Then we calculated R of OD, means for R of OD, R of OD is again there is a 3, this is the resistance 3 into 1 upon total resistance 6, means 3 upon 6 or 3 upon total resistance is the 5, means 3 plus 1 plus 1 plus 1 means 2 plus 1 3 plus 1 4 plus 1 5, means there are the 5, means here we calculated the 3 upon 5 which is equal to 0.6. Similarly for R of CO, means in case of R of CO the resistance is 1 into 1 upon 5, means 1 upon 5 we calculated 0.2 ohm. Means in this way we calculated from star to delta transformation for this network as well as this network. Then we have revised there R of AO which is equal to 0.6, R of CO which is equal to C of O which is equal to 0.2, and R of DO which is equal to 0.6 once again. And here this 1 ohm resistance, here is the 1 ohm resistance, and this 1 ohm resistance are connected in series with this and this. So here is 0.6 plus 0.2 plus 0.6, here again the 0.6 will come here, that is come in series with 1 ohm and 1 ohm resistance, and again in series with 0.6 0.2 and 0.6, means here 0.2 and this resistance are connected in series, and here is again 0.6 and this one are connected in series. So here for this 1 ohm the 0.6 plus 0.9 plus 0.6 that will become here, means how 0.6 and these are connected in parallel. So 1.2 and here is the 1.6, means 1.8 and here is 1.8, means again 1.8 and 1.8 are connected in parallel. So 1.8 into 1.8 means here to calculate this value, here 0.9. So we calculated here these two resistance, one point eight, 1.8. So here is 1.8 into 1.8, which is equal to 3.24 upon 3.6. 0.9. So here whatever the 0.9, this value will be substituted in series here. So .9 which is come in series here, there is a 0.6 plus 0.9 plus 0.06, which is equivalent to Vs into I, which is equal to 2, and this one is come 1.6 plus 0.9 and 0. There is a 3.1 ohm. So the source Vs that delivers the 2 ampere current through the circuit, and that can be obtained by Vs, which is equal to I into the total resistance 3.1. Therefore 2 into 3.1, which is equal to 6.2 volt. Means whatever the supply voltage, whatever asked, which is equal to 6.2 volt. The next example. In the next example, determine the equivalent resistance between the terminal A and B. A and B means in between the terminal you have calculated the equivalent resistance. Then you observe carefully. Here is the 4 ohm resistance and 2 ohm resistance are connected here. Means these are two resistance are connected in parallel motion, because according to the current divider rule, we have, let us assume that from this node the current is start to flowing. From this node the current will be divided, and where the current will be divided, the respective resistance are connected in a parallel motion. Same thing here. The next observation about that, in between the C, E and B, in between the node, the T network should be formed. In case of the T network, the 2 ohm resistance, 3 ohm resistance and 4 ohm resistance, and in between the 4 ohm resistance, here to calculate equivalent about that, there is a to find out the T2 delta transformation. In case of the T2 delta transformation, R of CB, then here is R of CB, we have calculated the 2 ohm, these are the 2 ohm resistance, RC plus RB plus RCRB upon RE. Means we have calculated in this way to form RCB. For delta is substituted for the Y between the C, D and E as shown in figure. The unknown resistance for Y2 delta transformation are computed as follow. There is a R of CB, which is equal to 2 plus 4 plus 2 into 4 upon 3. There is a 8.66, which is to be calculated. Then R of EB, which is equal to 3 plus 4 plus 4 into 3 upon 2, which is 13 ohm. And R of CE, which is equal to 2 plus 3 plus 2 into 3 upon 4, which is equal to 6.5 ohm. Then for the next, we have to be delta is connected in 3 terminal resistor to an equivalent Y connected network between A, C and E as shown in figure. There is a corresponding resistance we have to be calculated. There is a to the O, there is a 0.64 and 2.08 and 1.04 in this way. Then for the next, R of AO, we have to be calculated from, here is a delta will be formed, and from that delta the star network we have obtained there, R of AO, which is equal to 4 into 2 upon 4 plus 2 plus 6.5, which is given 0.64 ohm. Then R of CO we have calculated, there is a 4 plus this we have calculated R of CO, which is equal to 4 into 6.5 upon 4 plus 2 plus 6.5. There is a 2.08 ohm. Similarly, we have calculated 1.04. So R of AB we have calculated here. This resistance, the two resistance are connected in a series fashion, and again these two resistance are connected in a series fashion, and these two resistance are connected in parallel. So we have find out the equivalent resistance first, and that is come in series with 0.64 ohm. So now we can find the equivalent resistance between the terminal AB, R of AB, which is equal to 2.23 plus 2.08 in parallel with 1.04, means this 1.04 plus 0.93 plus 0.64 ohm, and which is given 2.21 ohm. Means these two resistance are connected in these are series. Here is also series, and again there is a parallel and coming in series with 0.64 ohm. Means equivalent resistance we have calculated 2.21. Then to find the value of the input resistance R of in between this, means here is the delta transformation, here is again delta transformation, and here is again delta transformation. First it is able to convert it into the star transformation. Here there is a first step, there is a 36, 26 and 12, second step 30, 15, 26, and third steps. Then again we have calculated the Y connected network from the terminal ABO is transformed into the delta connected, and it is connected in parallel motion just like this. Means this is the delta, and here is the star transformation. And to calculate it from here to star to delta, then again the equivalent two resistance are connected in a parallel motion. So here is these two resistance are connected in parallel, again these two are connected in parallel, and here is two connected in parallel. So R of in, which is equal to R of AC plus R of BC into R of AB upon R of AB plus BC plus CA, which is 19.37 ohm. Then here is the new form of the example should be given, and R equivalent resistance should be calculated. So first you have to be convert from star to delta transformation. Here is the 5 ohm, 2 ohm and 4.6 ohm, and that will be converted into the again star to delta transformation, and to find out the value R equivalent, which is equal to 7.26. I hope that all of you understand the transformation, the delta to star transformation and star to delta transformation with the help of these examples. And from that examples, any doubts, any query, please write on my comment page, and please subscribe my channel and click on the bell icon. Thank you very much.